Okay, so in the last video we looked at how you could look at the nature of turning points by differentiating, setting the gradient equals 0 because that will help you find where the turning point is, and then looking whether it's a maximum minimum point of inflection. So this is a question from 2008's exam paper to do just that. Now I've tried this a couple of times and I've never managed to get it into 5 minutes, so I'm going to have to split it into 2 videos. So in this first video we're going to go and find the coordinates of the turning points, and then in the second video we'll look at determining their natures. Okay, so first thing I need to do therefore is I need to differentiate, and that's always a good place to start. So because it's f of x, I'm going to work out f dash of x multiplied by the power, so it's 3x squared over 3 minus 4x minus 12. Now I've differentiated, I'm going to cancel that out, so I end up with the differential equation, or the gradient function, of x squared minus 4x minus 12. But I'm trying to find the turning points, so that I've got to set that equal to 0, because the gradient at a turning point is 0. Now looking at that expression, I'm going to guess that that can factorise, so my factors are 12 are 1 and 12, 2 and 6, 3 and 4. My sign is a minus, so that tells me the bracket has different signs inside it. So I've got x plus and x minus, and the only way I can get minus 4 is if it's x plus 2, x minus 6. So you'll remember from the algebra stuff that x plus 2 equals 0, which implies that x equals minus 2, and x minus 6 equals 0, which implies that x equals 6. So I've got my x coordinates. Now to work out my y coordinates, I need to substitute these values, my x's, back into my original equation. So I'm going to cheat, because the calculator does this so much better than I can, and I'm in the table function, and I'm going to type in the equation. So that is 1/3 x cubed minus 2 x squared minus 12x. So that's in there. I draw the table and I type in minus 2, and minus 2 gives me a y value. I'll show the mathematics of it, just in case you don't have a graphics calculator. So 1/3 minus 2 cubed minus 2 lots of minus 2 squared minus 12 lots of minus 2, which gives me a value of 13 and 1/3. And if I put f as 6 in there, do exactly the same. So I've got 1/3 of 6 cubed minus 2 lots of 6 squared minus 12 lots of 6, and that equals minus 72. So just to remind you why I put the brackets around it, if I didn't put the brackets around that minus 2 when I cubed it, it would have cubed the 2 and then stuck the minus in front of it. And the same with the minus 2 squared. Now in the minus 2 cubed, that wouldn't matter. Minus 2 cubed is minus 8. But minus 2 squared is not minus 4, it's 4. So you've got to make sure you put the brackets around, okay? And because I did it once, I did it twice. So I've got the two coordinates of minus 2 and 13 and 1/3, and I've got the second coordinate of 6 and minus 72. Right, that's me finding out the coordinates. In the next video, we'll derive their nature.